In order to optimize the design of this link component, I will select some key parameters to be varied, drive automatic updates to these parameters, and study the effect on the product's behavior. A common data model for design and simulation allows me to investigate changes to the design and the loading conditions and update the results automatically. The model container exposes all of the design parameters of the link component. For this example, I will investigate the effect of varying this pocket depth on the stiffness and strength of the part. The scenario container collects the loading and constraints required to describe a particular set of in-service conditions for the part. The design and the loading can be updated automatically to simulate many different load cases applied to many different designs efficiently. Through the result container, I can review the simulated response of the design to the applied loads and track any KPIs, such as the maximum stress and maximum displacement. A simulation process allows users to update design parameters and run a sequence of tasks automatically. The complete simulation data structure can be accessed and updated. Updates to design and simulation parameters can be driven using a simple loop, a design of experiments, or an optimization case. This process will automate updates to the pocket depth. Executing the simulation process runs all the requested design variants automatically. The results of a simulation process can be explored to study the effects of parameter changes on the key design KPIs and to identify the optimum design. I start by specifying the design requirements and objectives. In this case, I must limit the maximum stress and displacement whilst maximizing the pocket depth to reduce the weight of the link. If already defined, I can import the requirements from Inovia. Once the design objectives have been specified, I can explore the design points produced by the simulation process. The design points are automatically ranked based on design objectives. To gain an understanding of how design changes affect the product performance, I can review plots to highlight any correlation between inputs and outputs. In this case, I can see how changes to the pocket depth affects the resulting maximum stress and the maximum displacement. In addition, I can estimate the response of intermediate design points using approximation models. In this simple example, I only varied a single design parameter. However, a simulation process can drive updates to any number of design parameters, allowing designers to simulate and explore large numbers of design alternatives. Automating simulation of design updates allows designers to select the optimum design from a much richer set of alternatives. I can select a subset of design alternatives to perform a more detailed comparison and identify how well each fits to the design objectives. Finally, I can select and record my recommended optimum design. Having completed the design optimization task, I can now share the results using 3D Dashboard. From the dashboard, I can link to my Inovia tasks, attach my working data, and mark my task as complete to notify the project team.